I'm Andrew with AGL Mechanical Tips, and today you're going to learn how to flush and purge a geothermal closed loop system. Right here we have a flow center, and this is basically a pump and three-way valves combined into one unit. The pump can be installed anywhere on the system, but the three-way valves need to be installed in a place that you're not really worried about water splashing or dumping anywhere, because when you're doing this flush and purge process, it can get a little bit messy. So sometimes you'll find these units split apart. Basically what we have here is we have our three-way valves, and we have our ground loop that goes into the earth to get rid of the heat from the system. It comes right back up on this pipe here, and then up here, this is going up to the system itself. In some systems, you'll see just this assembly mounted on a wall. So this is a three-way valve assembly. And then you'll have a circulation pump mounted at the unit side. This is all the same. We're going to basically just be accessing the three-way valves here today. So we really like the self-contained units that have the pump and the three-way valve here just for the simplicity of it. But you have to run a wire from your indoor unit to this. And also, if we're in a flood zone, and I'm in Charleston, so we're in the lowlands, we actually do get into flood zone quite often. This isn't rated for flood use, so this will be installed elsewhere. When that occurs, we end up with just a separate three-way valve. So this basically is the same component that's inside this assembly, but it's mounted independently, and we'll actually put it on a bracket like this. This is a used bracket, but this is the whole three-way valve assembly all in one piece. You can also get them in different types. This is a foam-filled three-way valve, so it's insulated. It's basically everything that's inside here. It's just in a single, And then by the unit, you'll end up with the pump. So this is the pump here, just separated. This can be installed at the unit. Helps you out with your wire. You don't have to really pull a wire too far. We prefer a self-contained flow center whenever possible. This is a flush and purge cart right here. Don't be intimidated by it. We're going to run through every component and you're going to understand how it works. My goal in this video is to not teach you a process. I want to teach you how water is flowing through the system, because you're going to come across more complex systems and you're going to have to figure it out. It's not just going to be a simple one flow center and some pipes. Sometimes there'll be check valves and multiple flow centers and things of that nature. So I basically want to show you how all of this is functioning, and then from there you can make decisions on how to make it work. The first thing you need to know about the flush and purge cart is which way the water is flowing through it. Right down here we have a centrifugal pump. I have a smaller version of a centrifugal pump, and that's this right here, resembles this. And basically this has an impeller on it that spins very rapidly. Water comes in through the bottom and gets pushed out the outside using centrifugal force. So if you know that a pump works that way, then by looking at this pump here, we know that the pump's spinning right here. Centrifugal force is pushing the water towards the outside. So then we now know that our water is flowing in this direction. Now that we understand our flow direction, we don't need to memorize what every single valve does here. We just need to know what's going on, and then we'll be able to know how to use these valves. So basically how this thing's going to work is water is going to be filled up in this reservoir, and this pump is going to draw that water up and pump it through this pipe. It's going to come out, and it's going to go into our flow center here. It's then going to flush through our loops. It's going to come back and go right to here, which then goes back into this reservoir. So this valve here would be our return valve. This valve here is our supply valve. The other two valves we have is our reservoir drain valve, which is used at the end of this process just for cleanup. And then we have this valve here, which is normally used to prime the pump, and we'll get into that in a second. There's a couple different things we need to do to ready our cart here. We need some municipal water, we need some power, and we need to make some connections to our flow center here. This is a GL style flow center. This is a GL style fitting. This comes with a lubricant. I was actually surprised that it was a petroleum product. If it comes with the fitting, then I'd use what the manufacturer recommends, but I'm normally using a water-based product, especially at the PT ports. But like I said, this came with a petroleum product. I'm going to roll with it. take this off right here, and I remove this cap. I lubricated this fitting, and I'm just going to simply slide that in right like that. This is a hand tightened connection, and it leaves me with a cam lock fitting, also known as a fire hose fitting on the field. In some situations where these flow centers are in tight locations, we might opt for a straight fitting like this. So this is something that we built. It can be adapted. You can make it up however you want, but we normally have a couple different configurations just for different kinds of applications. And then sometimes when we have a three-way valve that is just completely split off, or what's called an FPT flow center, it has a female pipe thread, a completely different connection style. We have an adapter for that. This is 1-inch female or 1-inch male pipe thread that's simply going to thread right into here. So if this was mounted on the wall, we have the same setup here. We now have a hose connection here or a cam lock connection here. I'm going to hook up my other GL fitting here, and I wanted to mention that a lot of times I'll leave the hoses connected to this. I really only pulled it apart to just show you what a cam lock fitting was, but a lot of times I'll leave this assembly hooked up. But there's my other GL fitting there. Hand tighten that fitting. And I've got a hose here. Simply locks in place. What I was mentioning, I could leave all this assembly together, just haul it together, it all stays together as one piece, or I can break it apart. Got my other hose here. Now we have to make a connection to our cart. And does flow matter? Well, it depends on what you're doing, what kind of system you're working on. If there's a check valve determines which way the water's flowing, so it can only go through the system one way. This system, when it's not in operation, water can flow in either direction. So if I'm just doing a flush and purge and I'm not running the system during my flush and purge, the water direction in this particular system doesn't matter. I'm going to explain something in the tips section of this video though, and that's that you can actually run this system while this is flush and purging. And if you plan on doing that, there is a specific way in which this needs to be connected, but I'll explain that further along in the video. So we're going to make our connections to our cart here. We simply do that by just sliding that over like this. Take this other one, slide it right over like that. We're going to make sure it's good and locked. If flow direction did matter, remember we have a centrifugal pump here. The pump is spinning like this. Water wants to go to the outside, so our flow direction is now this way right here. It is coming back on this hose right here. I'm going to talk a little bit about our flushing procedure now. There is an actual procedure that this has to go through. I know I explained that I want you to learn how it's working, but you definitely want to flush your lowest point first because air rises. So, and what I'm getting at here is we want to flush our ground loop first and then shift to do our upper loop. This is why we have a three-way valve. This allows us to control our flow direction. And on this valve, there's a T here. And what that's doing is that's showing us which side of this valve is open. So with this T in this position, this and this and this are all connected. So this is the inside of the three-way valve, and when we rotate this, you can see that it's changing what is connected here. So if I was to set this like this, it's connected this and this, but this is nothing, so this is capped off. So we're basically just connecting these two right here. So we're going to start with flushing the ground loop. So we're going to adjust these valves to allow this connection part right here to only be connected to the ground loop portion. And we're going to isolate that from the upper portion of our loop. This valve here is a little different. It doesn't actually have a T drawn on it. It has little notches where it is allowing water to flow through it. And it has a 3/8 opening in the center. And this is what we use our 3/8 ratchet wrench to rotate it. And we're going to rotate this cylinder so that it is only allowing water flow into the ground portion of our system and our cart. So we are connecting our cart and our ground. Now that we have all of our hoses here connected, We have our municipal water, and we've already opened this up at the hose bib. We've got our power connected, but we have our switch set to off still because there's no water yet in this reservoir. So right here, behind this hose, you can't really see it, but there's a valve that is controlling my incoming water line here. And I also have a valve right here that is going to my reservoir. I'm gonna open this valve, and I'm gonna open my water supply here, and I'm gonna start filling this tank. A lot of this was hydrostatically tested during the well installation, but there's still gonna be some air in here. So during startup, we're gonna need to be adding water very rapidly. We're not gonna fill this reservoir up all the way. I'm gonna stop a little short here. And the reason being is when this first starts up, there's a lot of air getting forced into this tank. And I'm gonna try to avoid the situation of water ejecting out the top. Sometimes it's unavoidable, it just happens. But I found that if I keep this water level just a little bit lower, it's less likely to occur. Now, with that said, on initial startup, I'm gonna be valving down my discharge line a little bit to where this pump can't pump the water out the reservoir quicker than we're getting new water supply in. I'll show you in a second here. So at the bottom of this cart, I have two valves here. I've got my drain valve, which is used at the end of this process to get rid of all the leftover water and cart this off. And I have this other valve here. Now, there's also a plug right here. This is the prime plug for this pump. But I found that normally, if I simply open this valve here, it's allowing any vapor that's stopping water from getting through this pump, it's allowing it to come around and get into our pump. There's our air. So our pump is now primed. When I fire this up, it won't be drawing air. So we have everything hooked up, but we're gonna do just a real quick checklist before we fire this thing up, just to make sure we didn't forget anything. So I have my water connections here. I'm gonna open the return line to the reservoir because I wanna allow water to get back into this reservoir. We have power, it's ready to roll. I have my municipal water here. It is open at the hose bib on the building, but it is not opened here on this valve. And then lastly, I'm gonna be controlling this discharge valve coming from this pump. And the reason being is if there's any air still in this system, that's gonna get displaced with the water. And sometimes my municipal water supply won't keep up with how much water I'm pumping into my system. So this tank will eventually run out of water. And if I meter the flow, I can make sure that we still have some water in this tank so that it doesn't end up running this pump with air. We're ready to roll here. I'm gonna go ahead and give this power. Just know that at the beginning there could be splashes coming out the top. We tried to keep the water level low to avoid this. We ran our water level here, so hopefully if a splash occurs, it occurs inside the chamber. We'll see what happens. Let's go. I'm keeping a close eye right now on where my water level's at, and if it's getting low, I'm valving off my discharge a little bit, but we're looking great like that. I'm adding municipal water to it. All right, we're looking good. I've got my discharge wide open. I've got my return wide open. I'm letting my municipal water get right above the elbow inside this tank. We are now flushing the ground loop portion. So we're gonna wait about 4 hours.
That's what I have too. Thought maybe it was fast.
So my loop is mostly full now. When I fired this up, I opened up my incoming municipal water and I metered this valve so that the water level in here could keep up with the pump. I got the loop mostly full, and this is the part of the process where you just have to wait. So we've gotten 95% of the water out, but there's micro bubbles that are sitting on the inside of the pipe that through a very fast flow rate, we're gonna push all those bubbles out. There's also on a closed loop system, something that we call a header. The piping in the ground isn't one continuous pipe. It actually goes down into a header and splits off into many different other pipes. And water's gonna travel through the area of least resistance. So if we have one loop on that header system that's shorter than the others or something, water's going to want to go down that loop rather than going through the other loops. So we have to use a very high flow rate in order to press this water through all these loops evenly. And this just takes a lot of time. So depending on how big your loop system is, we could be waiting here for 4 hours, could be waiting for 5. It really depends on how big the system is and how big of a pump you have running and how well it was piped and how evenly your header was done. So right now we just got a lot of waiting. Before we do that waiting, I'm just going to double check to make sure I've got no leaks here, because if I have leaks here, then all this time that we're about to wait could potentially be wasted. So I'm just going to double check my connections, and then I'm going to go and start wiring up the system or doing something else on the job and come back to this. So let's say we're on the job. This thing's been running about 3 hours, 3.5 hours maybe. And how do we tell if this is done flushing and purging? Well, there's no way to be absolutely certain that you've gotten 100% of the air, but there is a good indicator, and it's called deadheading. What we have here is we have our return valve to the system, and if there's any air left in our system and we close this pump is still pushing water through these lines and into our loop field. If there's any air in our loop field, it's going to compress that air. And when it compresses that air, we're going to see our tank drop slightly. So if there was no air in the system, it was 100% water, there's no air to compress, our tank isn't going to drop as much when we deadhead this valve here. One thing I want to mention about deadheading is you're always going to see a drop in this tank. So it's not going to show you exactly how much air is in the system. You're always going to have a drop. It's good to get a good idea at the beginning of the system startup of how much your tank's dropping, and towards the end of after it's been running 3.5 hours. So the reason you're always going to see a drop in your reservoir tank is because if this was like a 4-ton system, our ground loop heat exchanger might have literally like 2,000 feet of high density polyethylene pipe buried in the earth. Well, that pipe, it does expand with pressure. So over the course of 2,000 feet or something, we're going to get some pipe expansion. Now, it's not going to be as drastic as air. So like I said, deadheading is a good idea to get an idea of where we're at here. It's not going to 100% tell you that your loop is flush and purge. Really, the more time you can flush and purge a loop, the better. One more thing I wanted to mention is your water level needs to stay above this pipe. The reason being is if the water level is below this pipe, the air in between here and here, even though it's just microscopic bubbles, you've got splashing that is pushing into that water, and that's going to release microscopic bubbles into your water that's going to just flow right back through the system. So it's important to keep your level above the 90-degree elbow in this tank. I've got less than a 1-inch drop on my deadhead. It's been running for a couple hours. I feel confident the ground loop portion's covered. So we're going to switch this over to do the upper side of our system here. So what I normally do is I'm going to shut off my return line here. And what this is going to do is it's pressurizing our loop here. So there's a lot of pressure on this system right now. I'm going to go ahead and close off our discharge from our pump as well. And I'm going to cut our tank off. So we now have this under pressure with our ground loop side here. And the reason I'm going to put this under slight pressure is when I open this valve, if there's any pressure on the system, it's going that way. We're not introducing air into our system. So I'm going to go ahead and valve this so that we are only connected to our unit. And I turn the valve in a way that where it turned the ground loop side off and open this side up at the same time. So it was never actually connected together at any point. Now that our 3-way valves are turned to do the unit portion, it's the same process. We're going to cut this on. We're going to open up our return line. We're going to allow our water to flow through our system, and we're going to add municipal water until this reservoir is filled up above this elbow. So I explained when we're flushing our ground loop portion that there's a header. What's nice is when we're doing the unit side, there's no header. It goes up to our unit, it goes around a coil of pipe, and it comes right back down. So flushing the upper portion of the unit is normally a very fast process. I'd say in the first 3 minutes it's probably flushed and purged, but we go ahead and run it for about another 15 minutes if we have time. It's probably good practice. Once this side has been flushed and purged of all the air, we repeat the same process. We're going to close off our return, which is going to pressurize our upper loop portion. We're then going to close this discharge line off. We're going to shut our cart off. The last part of our flushing process is connecting the cart with the ground loop and the coaxial upstairs. This is just to get any residual air that might be stuck in the three-way valve or anything like that. It's just good practice to connect all of this together. We're probably going to flush this for another 15 minutes. We'll deadhead it just to triple check, and then we'll shut it down and seal this thing up. So this flush and purge cart has been flushing the whole portion of my loop field for about 15 minutes. In fact, I had some job cleanup to do and it took me a little longer, so I just let this thing run. This should be about the last thing you do on your job because it doesn't hurt for the flush and purge cart to run longer. If you can let this thing run for 8 hours, let it run for 8 hours. It can only get more air out. So we're at the end of the day now, everything else is done. So I'm gonna use the same procedure I used every time I turn the three-way valve. I'm going to close my return line going to my reservoir. I'm going to close my discharge line. Once again, cut the cart off. After your cart's cut off, you're going to go ahead and turn these three-way valves to where your access port, that is where your hoses are connected, is in the off position. Once both valves are in the off position, we'll go ahead and break the pressure here because there's still pressure on this. We'll go ahead and relieve that pressure. And then we can go ahead and disconnect all of our hoses, drain our reservoir tank, and clean up the rest of the job. So I know I just mentioned that the absolute last thing you should do would be to disconnect the part, but there's one step I forgot that occurs after the cart is disconnected. And that's bringing your system pressure up to 50 PSI. This is an inducer pump. This is used to pressurize the system after the flush and purge. You gotta make sure you get this right because there's a way that you can inject air into your system. And if you do, you're restarting your flush and purge all over again. So basically you wanna fill this reservoir up with water all the way to the top. You want to pump it until you have nothing but water coming out of here. You have to get all of the air out of this hose. You are then going to insert this into the PT ports at the front of your unit, and you're going to inject water in this until you get up to about 50 PSI. This system, after it runs the first year, the pipes in the ground might expand a little bit and you're going to lose a little bit of that pressure. During maintenances, it's always a good idea to re-induce the pump and bring it back up to 50 PSI. So now I got a couple tips to go over to make this process a little bit easier for you. One of the biggest things is start your flush and purge early. When we do a geothermal change out or something, we get the unit installed and the first thing we do is we go into getting that coaxial piped in, getting all of our piping done. We get our cart up and running. Once our cart's up and running, it's flushing the closed loop portion. We'll move on to do the wire and the ductwork and all that other stuff. To get a little bit longer run time out of your flushes, you can actually run your flush and purge cart while the system's running. So towards the end of the day, when you've gotten the system ducted in and it's hooked up, you've already flushed your ground loop, you've already flushed your unit side. You now have your T's connected to where your cart, your ground loop, and your upper loop are connected. You can run your flush and purge cart at the same time, just get a little bit more air out the system. But there's a way that you should pipe your flow center in to do this, and it really depends on the system. If it's a simple system like this, you can do it all day long. But you want to make sure that the discharge line, the line leaving your centrifugal pump, is ducted or pumped into the same side that is leaving your pump. So these water streams need to be fighting against each other here. So your return side would be here. So here's your flush cart. That's your discharge. It is pumping water in and going with the flow of this pump here. And then returning coming up here. This pump will still be able to pull water here. If you do it the other way, let me show you the wrong way of doing it and why it is important to get this right. If we pipe it in this way, our discharge from our pump is going in here, facing the return side of our pump. Here's what's going to happen. This is our ground loop here. This is our unit right here. This water is going to travel into this T. It's going to go straight up into this pump. It's going to go into our unit. It's going to come right back down. It's going to go right back to our cart. So it's not damaging anything, but what's going to happen is we've got no more heat transfer going on. We're not pumping any water into the ground anymore. If we're pumping a little bit, it's not going to be enough to keep up with the load that the unit is putting on it. So what's going to happen is this water is going to get hotter and hotter and hotter. Your unit's going to go out on high head pressure. Another big thing, and this applies to anything really, modify your equipment. This is a simple cart. This is actually our workhorse. This is what we're normally using. This is actually a backup cart. That's why it's nice and pretty. We've heavily modified this cart to fit in many different applications. I showed you a basic flushing and purge setup because I wanted you to understand just the basics of this. And you'll learn more and more as you progress in this. So you'll come across a system that was piped in wrong by the previous installer, and there's no easy way to flush and purge it, or you might come across a system that has a check valve in it. And the reason we have this cart and it's configured the way it is because if we have a check valve, this four-way valve right here allows us to instantly reverse flow. So this is something we've done to our cart to modify it, just to allow us with check valve systems quickly modify flow. Also, when we're flushing and purging just a standard system like this, we reverse the flow a couple times during the flushing and purging process, just in case like bubbles, micro bubbles are sitting around an elbow fitting or something, and we reverse that flow, we might get better turbulence through that fitting in order to release that air or something, you know? So there's that. Another big thing is set yourself up with tons of adapters, tons of different fittings for tons of different scenarios. We got 45s here if the flow center is too close to the wall and we can't get to the ports. We've got, you know, a brass reducer here in case we come across a real big three-way valve that wasn't set up for a regular 1-inch stuff, you know. We've got 1-inch cam lock to 1-inch male pipe thread. This is for the FPT style flow centers, female pipe thread style flow centers. You know, then we've got our straight GL, which I showed in the video earlier. We've got a 90 GL. You know, we're setting up for tons of different scenarios. We also have longer length hoses around here. We try to use as shorter hose as possible because we're getting better flow rates, but sometimes three-way valves might be in a garage and you don't want to get water because it's like somebody's gym or something, who knows? And sometimes you have to use longer hoses. The problem with modifying a cart like this is this cart does get a little heavy. You could actually take a four-way valve like this and just keep it separate. You would install cam locks on each side. And if you had two sets of hoses, then you could bring this only to the job that has the check valve in it that you want to use a four-way valve. And this can just lay on the floor separate from your cart. We've done it, works great. I don't have this hooked up anymore just because we've been running off this four-way valve for quite a while now. And then lastly, we've modified this cart even further. And on the back of this, we have a receiver assembly. This assembly allows us to hook this up to a truck for hauling. We don't have to put it in the bed of a truck no more. We just drive it down the road. The one downfall to this is it does greatly affect weight of the cart. So our next design, we're going to find a way to offload this into an assembly that stays on the truck. And the cart just rolls up to it and it basically hooks into that. If you enjoyed this video, hit the like and subscribe button. We've got much more content coming up. I'm going to be going over how to fuse this pipe together, and I'm also going to be doing some sheet metal layout. I'm Andrew Lingle with AGL Mechanical Tips, and remember, quality is your reputation.